Today's lesson is going to be about the nth root, and so what that means is it could be like the 5th root, it could be the 10th root, it could be any number n, which we're calling the nth root. So here's your title page, your title and your essential question. You can go ahead and hit pause and copy that down. And then here's some more notes that you need to copy down. It's got some vocabulary in it, the index, the radicand, and the radical symbol, and how x to the 4th works and how it works with the 4th root, and so on with that. So copy all of the highlighted information down. Again, hit pause. And then some more. The definition of the nth root. And you can go ahead and hit pause, copy down the highlighted information, and then I'll scroll down. And then there is the rest of the information to copy down as well. Okay, so let's go through this problem. So simplify plus or minus the square root of 16x to the 6th. So first of all, this plus or minus tells us that the answer is going to be plus or minus. Then we think about the square root of 16 and the square root of x to the 6th as separate entities. So we're going to say plus or minus 4. And then what does the square root do to the exponent? Well, a square root, we have to remember, is like a 2 in there. Okay? And so what it does is it takes the 6 divided by 2. So this is going to become x raised to 6 divided by 2, which is going to be x to the 3rd. Okay, now there's a rule that we have to remember. If we go back to our original equation, then we can see that you have to take the square root of it, and to be a real answer, you cannot put a negative number in here. And so we have to look to see, is there any way that we could have gotten a negative number? Since x can represent anything, if I put a negative number in there, could it potentially end up taking the square root of a negative? So how about if I just threw in negative 5? It has to be taken to the 6th power and then times 16. Will that come out negative? And in this case, no, it'll always be positive. So we don't have to worry about anything extra. We'll get to an example later where we will have an extra thing that we need to do. Okay, next example. And so we've got minus. It's going to tell us that the answer is going to be minus. This is a square root, so what it's going to do is come over here and cut this in half. So really what you're going to have is q to the 3rd plus 5 raised to 4 divided by 2, which is 2. There's our answer. And could we make this negative in any way? Well, because we're taking it to the 4th power, even if inside here became negative, anything to the 4th power is going to become positive. What happens to be a problem is when it is raised to an odd number inside there. Okay, let's try this one. So let's split these apart. The 5th root of 243, the 5th root of a to the 10th, and the 5th root of b to the 15th. So we type this into our calculator. If we go back into our notes, we can see right here that this rule, b to the 1 over n, is the nth root of b. And so we can use that backwards, as it's written there. Oop, I went too far, sorry. What you want to type into your calculator is 243 raised to the 1/5. And you're going to want to use parentheses around the 1/5 or you end up getting the wrong answer. So take out your calculators, probably hit pause here so you can have time to calculate that out. And then you should get the answer of 3. Okay, so then this one is going to be a raised to 10 over 5, or a squared, and then b raised to the 15 over 5, b cubed. Okay, now we have to go back. We can put all of these together. Let's see if they're detached. Good, they're detached. And we have to decide if there's any way that this could have been, if it's a problem, to get a square root of a negative. Since it's the 5th power and that's odd, it doesn't matter. It only applies if it's a square root or an even root of a number. So that is our final answer. And how about the square root of a negative? So notice that is different than the problem that we had back here, where there was a negative outside. Negative inside is a whole different thing. That means that we're going to have complex roots. So it's like the square root of -1, square root of 4. So this is just a review for us, hopefully. Square root of 4 becomes 2, square root of -1 becomes I. There's our answer. Okay, our next problem. Okay, so looking at this problem here, we have the 6th root of t to the 6th. So this becomes 6 over 6. This comes down here in the denominator. And so that becomes t to the 1 power, or just t. So now, if we look up here, could we have a negative up here and take the 6th root of it? Because it's an even root, we can't do that. And because this is an odd exponent here, 1 was odd, so this is even, this is odd. That means we have to put absolute value bars around it, just knowing that the answer is never going to come out as a negative number. Even though our simplified answer looks like it could be negative, the original answer could never be negative. But this one has an odd exponent, so we don't really need to worry about that. I'm sorry, I said odd exponent, but I meant odd root. So since this is odd out here, we don't have to worry about absolute value bars, but we can do the same thing. 243 raised to the 1/5, and then x plus 2 raised to the 15/5. So we already calculate 243 to the 5th is 3. And then this would be x plus 2 raised to 15 divided by 5 is 3. There's that answer. And on to some word problems. Designers must create satellites that can resist damage from being struck by small particles of dust and rocks. A study showed that the diameter in millimeters d of the hole created in a solar cell by a dust particle traveling with the energy K in joules is about that equation. Estimate the diameter of the hole created by a particle traveling with the energy of 3.5 joules. Okay, so looking back here, K is joules. We've got some joules here, so we have to plug them in. So D equals 0.926, the third root of 3.5. Okay, so if you want to type that into your calculator then, you type in 0.926, and then you take 3.5 raised to the 1/3. So type that all into your calculator, and you should get the answer of 1.237. That's how much of a diameter it would have. Okay, so let's this one. It has a diameter of 2.5. Estimate the energy. So we'll work backwards on this one. 2.5 this time goes in for D. 2.5 equals 0.926, third root of K. Oh, I realized I missed something in that last problem. I missed this whole part right here. Okay, go back to that. When you type that in, you probably were wondering why you got the wrong answer. I forgot to put this part with it. Okay, so that you should type in and you should get 1.237. All right, back to this problem again. Sorry about that. Going along, and let's add that 0.169. All right, and now we're going to drop down our line and solve this. So I'd start by adding 0.169. And we get 2.669 over here. Okay, and then we divide both sides by 0.926. And that comes out to be 2.88. Now, when you're doing this, hopefully you have that 2.882289417 in your calculator. Don't cut off the decimal yet. Even though on paper we're cutting off the decimal, keep it in your calculator. And then how do you undo the cubic part of it? Cubic root? We cube both sides. Okay, and so then just take your answer raised to the third power. so that you keep the entire decimal, you end up with 23.94 is our K. All right, and that is the end of lesson 7.4. You can write your questions and your summaries.